Fellow students, welcome to this lecture. This is Prof. Tabit speaking. Over the years, I've seen many students, many of my master's and PhD students, struggling to decide on the correct statistical analysis for their research data. Sometimes it is impossible to be aware of the type of statistical analysis you will use at the time you are formulating your research objectives and hypotheses. So many students struggle with this. So what I'm going to say is that it's important that you know upfront the type of statistical analysis you will use when you are formulating your research objective and your research hypothesis. So before you proceed with data collection, you should be able to know the type of statistical analysis that you will use. The problem is that many postgraduate students often only think of what statistical analysis to be used only when they've already collected data. And that can be very problematic. So postgraduate students should be able to identify the dependent and independent variables in their research objectives, as well as they should be able to identify the type of data scale to be used for data collection. And on top of that, the student must know the type of relationship between variables that they want to analyze. So in this way, they'll be able to select the correct statistical analysis for their data. Against this background, I've decided to present the lecture entitled Guidelines on Choosing the Right Statistical Analysis for Your Research Data. Okay, so we proceed. So the first thing that I want to touch on would be the steps to follow in selecting a correct statistical analysis for your data. Okay, so these steps are very important as you prepare your research proposal, because at this stage, you have written your research objectives and you are about to make your hypothesis. Because before you make your hypothesis, you should know how you are going to test this hypothesis. Okay, so I just want to make a distinction between the general hypothesis, maybe a hypothesis in language or other disciplines, to that of science. I mean, in science, we make a hypothesis that should be tested, and you test it using a statistical model or a type of statistical analysis. So that's what we do in science. Okay, so these are the steps to follow, or the things that you must know before you can start to decide on what statistical analysis you want to use for your data or for the data that you will be collecting. The first one is to identify the dependent and independent variables in their research objectives. This is very critical, because if you don't know the dependent and independent variables in your research objectives, it will be impossible for you to know the type of data that you are going to collect. So when you state your objectives, the first rule of thumb is that you must have a dependent and an independent variable in that research objective. Okay, so then the next thing, after you've identified your dependent and independent variable, the next thing that you must identify is the scale of your data, the scale that you use to collect the data for both your dependent and independent variables, because you have to collect data for both the dependent and independent variables. So you must know the scale. So the scale can be continuous scale, ordinal, or nominal scale. And this will automatically translate to continuous data, ordinal data, or nominal data. Okay, so the moment we know the type of scale that we use, we also need to identify the number of groups or factors in your independent variables. So you can see here that if you are still struggling to differentiate between your dependent and independent variables in your objective, then you will not be able to know which one is the independent variable. And as such, you will not be able to identify the groups or factors in your independent variable. It is very critical to identify your independent variable and also to identify the groups or factors in that independent variable. And for an experiment or a survey, for statistical analysis to be possible, for some statistical analysis to be possible, you need 2 or more groups, okay? And for other statistics analysis, the dependent variable, the independent variable can be only one group, okay? So, but the bottom line is your independent variable must have 1, 2, or more groups. So, and you should be able to identify them up before you proceed to decide on which data analysis model you want to use for your data. Okay, so it's very important for you to identify the groups or group in your independent variable. Okay, so the next thing is the relationship to be exploited. You know, when you do a survey or an experiment, you want to look at the relationship between the dependent and the independent variable. So, but what is it that you are exploiting, or what is it that you are investigating? Okay, so the relationship can only be in the form of variance. It can only be in the form of association, correlation, or prediction. Okay, so we are going to see more of these: variance, association, correlation, and prediction, which will determine the type of statistic analysis that you can choose for your data. Okay, so I just want to present this variable and statistical analysis plan. Okay, so after you've done your problem statement, now you know the problems that you want to investigate. Then from there, you've set research objectives. Now, for each research objective, you must come up with a variable and statistical analysis plan. And now, so let me just put the pointer on. Okay, you see now we are under the independent variable section. So you go to your objective, you identify the independent variables. Sorry, the dependent variable. The first one is the dependent variable. So you must identify the dependent variable or variables. It could be 1 or 2 in that research objective. Then you list them. Okay, but to be safe, it's better to formulate a research objective in which you have one variable at a time. Okay, so you can have one variable, let's say 1. Then you go to the independent variable, you can also have 1. It can be more. Okay, then the next thing that you need to look at the number of groups or factors. So we are saying for each independent variable, it must have groups, either 1 group, 2 or more. So you identify the groups in your independent variable and list them. Okay, then after you've listed the group, then what relationship do you want to investigate? So the 3 broad categories are the variance. Okay, for the variance, you are looking at variance between groups or factors in your independent variable. So in relation to the dependent variable. So, but we are going to see more of that in the slides ahead. Or you're looking at association between groups. Okay, association between groups can be a chi-square. Chi-square is one of the association between groups. You know, so for instance, if your groups are categorical, you can use chi-square, but we are going to see more of that. Or prediction. Prediction is a kind of a regression. You know, you do regression analysis. So your independent variable is used to predict the dependent variable. So, but we are going to see more of that. So this is the kind of table that you must try to design to be able to determine which data analysis method you are going to use for your data. So it's very important to break your research objective apart and use this table and find out, because if you don't know the number of groups that are there, it will be impossible for you to decide on certain statistical analysis. We are going to see it in the slide ahead. And also, especially for number one, the type of relationship, the variance between groups. So you see that if, for instance, you have a research objective that that the independent variable have groups, okay, or one independent variable has groups, then you know that you're looking at variance between the groups or the factors. So it's very important to know whether your independent variable has got groups or factors, and the number of groups or factors is very critical for you to know that. I cannot overemphasize this, okay? Because some of the relationship will be based on those groups of factors, especially when you are doing variance, when you are analyzing variance, okay? But not so much for association, okay? Because for chi-square, you also need groups, but two categorical groups. But for correlations, one group may be enough and to do the correlation, okay? Even for regression, one group of the independent variable can be enough. So, but we'll see more of that ahead. So, but you have to break your dependent and independent variable apart, especially your independent variable. You need to identify the groups that are there. Okay, unless you are doing only, maybe you are doing correlation. If you want to do an analysis that is other than correlation, then you should be able to identify groups out of your independent variables. Okay. Okay, so now I think we just need to look at broadly the different type of data analysis methods. Okay, so but we just need to recall that data analysis permits the interpretation of data collected in relation to answering your research hypothesis or research questions or research objectives. So you set a research objective that you need to achieve. So you can only achieve that research objective after you've done data collection. Then in that way, you'll be able to answer your hypothesis. Then you can make a discussion, a result and discussion out of that. Okay, so we have the primary data analysis method. So these are the primary methods that we use for data analysis. So the first one is qualitative data analysis. Okay, for those who are doing qualitative research. Okay, when you're doing qualitative research, your data set is in the form of a narrative. You know? So qualitative, analyze data collected using open-ended questionnaire during an interview or observation. So for those people who are doing qualitative research whereby you interview people using open-ended questionnaire, then the data that you collect will be in a narrative format, so in the form of a text, you know, a form of a story, and you must analyze that text. Okay, so we are going to see how that can be done in the slides ahead. Then the other type of data analysis is the quantitative. Okay, quantitative simply means that we are going to be dealing with numbers. Our data set will be in the form of numbers. Okay, and we analyze data from measurements. So we get numbers when we do measurements, especially for experimental research designs. Okay, And then we also have rating scales for survey research design. So you know that rating scales, nominal scale and ordinal scale, also give us numbers. So we also consider those numbers as quantitative data. Okay. So qualitative data is obvious. I mean, narrative format. So I don't think this is difficult to understand. The differences between them is clear. Okay, so I just want to show you how you capture your data on Excel. So V1 is the number of respondents or the number of samples for those who are doing experimental design. Then you have the variables here, C1, C2, C3. So where you see letter A, B, C, D, E, F in any kind of a spreadsheet, you know that beneath them you should have your variables, and then you capture your data. This one is a typical questionnaire data capturing sheet. So for each respondent, you put the outcome in a, use the rows to put the outcome for a particular respondent. Okay. Now let's zoom into qualitative data analysis. Okay. So to perform content analysis, so qualitative data analysis, the one that I'm going to talk about is only content analysis. I'm not going to try to zoom into the others, but if you can understand the way content analysis works, then you'll be able to understand the other ones. Okay. So we use qualitative data analysis. We do to perform content analysis and coding. So some people may be worried on how are we going to analyze content. Yeah. So you analyze content by picking keywords and then you code them. Okay. And then you study the code. So codes can then be further categorized into code categories. So you code words, you can group them into certain categories. Coding means you give them certain numbers. Okay, you give them certain code name. Okay, we usually use a combination of numbers and letters to get code names. Then code can be analyzed quantitatively. So if we, for instance, we have a particular story, there are certain words that we are looking for. We give those words. We say if somebody is telling a story about a journey, these are the words that must appear in that journey. Then we interview 5 different people. We are looking for those common words. So you see that now that those coded words become some sort of a variable. Then we can give them numbers. So we do have softwares that can be used for coding. Some example of qualitative softwares are the Vivo, Atlas, Quicos, and Maxda. Okay, there are many of them. So what they do, you key in certain words and then they code it for you. Okay. Then the codes are labeled. The codes are labels used to characterize qualitative data. So, like I've said, that we use words, single words, combination of words. Those are words that we extract from the text. You know. So, in other words, those are the data we are collecting for a particular variable. Okay. The variable could be journey experience or something like that. You see, so all the words that identify journey experience will give them code. And then we'll start to analyze how much of each word is can be found in the narrative of different respondents. Okay, the coded words are later on used to derive things. Okay, so it's still just grouping them. You can start from basic words and then group them into common themes and so on, and analyzing whichever way you want. Okay, so data coding, qualitative research. Okay, I've already said codes are labels used to characterize qualitative data. Okay, I've already mentioned the types of coding in qualitative research. So there are basically three types of coding. Okay, we have deductive coding. Okay, these are pre-existed codes used. If you are using pre-existed codes, maybe from a previous publication or maybe from a book, okay, you want to do interview people, but you already know the number of coded words that you are going to use to analyze the text that you've obtained from these people. So we call them deductive coding. Inductive coding, these are codes that are created from a narrative. So which means that you don't have pre-existed codes. So you read the narrative of of the people, and then you create coded words as you go along, you know. So in inductive coding, you create your own codes. You choose the words and give them codes. Okay, so you create your own coded words. So, and you do that from an interview or a published text. So if you are doing a qualitative research on publications, or maybe using a book, using information from a book or from newspapers. So you can also do qualitative research. You can also do coding from such documents, or you conduct an interview, then you get your own narrative, you know, and do the coding from there. So that's how qualitative research works. So for those people who are saying that they're using mixed research method, it means that you must have a component of qualitative research in your research proposal. Okay, so let's see an example, quantitative data collection. So this is a research objective from a quantitative research. The objective is to investigate the consumption of street vended food by university students. Okay, so they're going to use an open-ended questionnaire. I mean, they're going to use an interview guide with open-ended questions, you know. So what is your gender? Which level are you in the university? Why do you buy street vended food? You know, and people will say their own things in a narrative format. Okay, so you see that the data for question 3 will be in a narrative format, question 3. Okay, yeah. So that is a qualitative data. Okay, so this is how the data set was captured. Okay, so you look at question 3. The first student said that I like the taste, it is nice, it is easy to get. The second student said it is cheap, just available around the corner, it is not expensive, available near me, easy me, cheap, not enough time to cook. So now I must warn you that this is where the coding was done. And as you can see that a coding can be done by somebody who is an expert in that discipline. Okay, if you are not an expert in that discipline, you will not be able to do coding. So these are the various words that we think that we best describe. We best describe we best describe the variable under research, which is why buy street vended food. The reason for buying street vended food, actually, in actual fact. So the research variable will be the reason. So the reason is what we are investigating. So it becomes our dependent variable. That's what we are investigating. Okay. So street vended food. Why do you buy street vended food? So we have consumers of different age, different university. So those are their social demographics, you know. So those social demographics will automatically be their independent variables. Okay. So let's go back to see how coding was done. So you see, they choose nice taste as code 1, easy to get as code 2, cheap as code 3, and available code 4. So this is question 3, coded code 1, word code 2, code 3, code 4. So this is kind of a coding. So let's see how the coded words can be analyzed. There are different ways that it can be analyzed. So the first and easy one will be frequency distribution table. So you can see now that I have a frequency distribution table, I can see that the majority of people, they buy street vendor food because the thing is cheap. And the next one is readily available. Okay. So it makes sense. So you can see how you can start to use, you can use qualitative data and then transform the data through coding, and then you end up doing a kind of a quantitative analysis. So it's unfortunate that if you do coding, you must come back to quantitative analysis at the end, even though we call it qualitative research. Unfortunately, those who are running from qualitative research, you can't run. Okay, so you see the frequency distribution. Then there's another way you can code this. You can transform the data, because that one we just did the frequency distribution. You see, so now you can have a hypothesis in which you can say that you want to find out how many people think that you want to find out if people buy street vendor food because it's cheap. So you can use this coded word to say, okay, if anyone is saying cheap in the narrative, or put 1. But if they didn't mention cheap, then I will give 0. Then you end up with the data like this. You see. Then from there now you can start to do statistical analysis to find out whether cheap was significantly different, more than the other one. Then for you to conclude that it is the main reason, or the principal reason. So that is an example on how you can transform coded words and analyze them. Okay, so we go back to our quantitative data, which is the main one. So for quantitative data, you can get it through experimental research and even survey, like I said. So let's look at the experimental one. Okay, an example will be to investigate the effect of temperature and pH on the viscosity of tomato ketchup. Okay, so viscosity is the phenomenon that we are investigating. So viscosity will automatically be our independent or our dependent variable. Okay, so the effect of temperature, so it means we are going to set up different temperature and pH and then check viscosity. So we are going to measure viscosity. So viscosity will be our dependent variable. The data will be in the measurement format. So this viscosity is measured. So we are going to get a kind of a quantitative data. Okay, we are going to get figures. Let me put it like that. So temperature will also be measured. Remember, we also measure our independent variable as well as our dependent variable. So we measure temperature, we're also going to get numbers. pH, we're also going to get numbers. So this is a typical quantitative research. And this is how you capture the data on Excel. So I told you that when you have A, B, C, D on any of these type of spreadsheets, then you know that the variable must be under those letters. Okay, even with SPSS is the same thing. So this is experimental design, how you capture your data. Okay, so now let's look at the survey design. So for a survey design, it would be, the instrument will be questionnaire. Okay, the instrument will be a questionnaire. So you have a research objective: investigate the desire of ice cream by pedestrians. So what are we investigating? We're investigating the desire of ice cream. So this one becomes our dependent variable. So pedestrians and their social demographic automatically, or the social demographic of pedestrians will automatically be our independent variable. So here they are. Okay, what is your gender? What is your level of education? Do you desire ice cream? Strongly agree, strongly disagree. So you can automatically see that this one is an ordinal scale. Okay, because the responses are in certain, the response options are in kind of an order. Okay, So hence we set nominal / ordinal scales. So for the demographics, we mostly collect, we are going to collect nominal data, because 1 and 2, male and female, there's no order there. So it's just a list. Okay, what is your level of education? Primary, secondary, high, university. This one is an ordinal data because there's some order from primary to secondary, from secondary to high school to university. Okay, some of these scale type, some of these scale types can determine what type of statistical analysis to use. But I think it's good to just know the type of scale that you're having. Okay, because it can make a difference between choosing one statistical analysis and not the other one. Okay, so this is how you capture it. So we said gender was a variable, education was a variable, desired rating is a variable. So all the variables must be listed under the letters. And then the respondents will be listed where you have the serial numbers. Okay, quantitative data analysis method. So what are the different methods one can use to analyze quantitative data? So most often you should have a descriptive statistics. That's the first thing, because you use the descriptive statistics to look at the means, the median, the mode, the standard deviation, frequency, distribution, and stuff like that, percentage count, and whatever. It gives you a bigger picture of how your data pan out, you know. Then the next one is we have analysis of differences. This is what I call analysis of variance. Okay, you analyze variances between groups, and the groups are the groups in the independent variable. So how they respond to the differences on how groups in the independent variable respond to the or relate to the dependent variable. Okay, then you have association, which is you have the chi-square and the Fisher's exact. Okay, so this one they look at relationship between categorical variable. Okay, so you must understand what a categorical variable. A good example is for the independent variable gender. Categorical variables will be male or female. Okay, so you can have maybe you can have a variable that you're looking at, maybe drinking. They want to see whether there's an association between gender and drinking. So that you use categorical variable male and female to assess that. Okay. Then you have correlation. Okay, correlation, you just look at the relationship between two variables. For instance, gender and drinking. And in correlation, you don't really bother about the groups in the independent variable. Okay, you don't bother about the groups. Then for regression, you can bother about the groups. If you like, you don't bother about the groups. Regression makes it possible for you to break out the groups, okay, and factor them as individual variables. But you can still do it without breaking down the independent variable into groups. Okay, so regression can work either way. Then some advanced ones are the multivariate applications. So in most of the ones that I've mentioned, okay, they can take up to 1 or 2 independent variables. Okay, like analysis of variance, we have Two-Way Anova can take 2 independent variables. Otherwise, most of them will go with chi-square correlation. You treat 1 independent variable at a time. For regression, you can have multiple regression whereby you have multivariate regression with two or more independent variables. So it is possible, two or more independent variables is possible for regression. For ANOVA, it's only two-way ANOVA. Then now you have multivariate when you have multiple factors. You have multiple factors. You can have multiple factors of one variable, or then you can apply this multivariate analysis. Okay. So what I'm saying here, by the time you conclude on your hypothesis, you should already know which sampling, data collection and data analysis method you will use. So if you've done your research, you've written your introduction, you've written your problem statement, now you've written your research objectives, you've also written your hypothesis, you can't really do a proper hypothesis without knowing the relationship that you want to analyze and the type of data that you will use. You can just know the category of analysis without really going to the details, because sometimes the data set will dictate which particular analysis you will use. So you might not know that beforehand. So, but you should be able to pinpoint that I'm going to use ANOVA, one-way ANOVA, or I'm going to use chi-square, I'm going to use Spearman correlation, depending on the relationship that you want to investigate. So you should know that by the time you are formulating your research hypothesis. Hence this lecture. Okay, so let's go to the crux of the matter now. We are looking at a statistic decision. Okay, now I want to look at variance between groups or factors. Okay, and now we are assuming that we have parametric data. For those who have not listened to my previous videos, parametric data are data that we work with means and standard deviations. Okay, so all the data set that you have numeric data, figures that you can calculate mean, that mean the calculation of a mean will make sense, then know that you are dealing with the parametric data. Okay, if you are dealing with categorical data, you can't do mean there. Okay, for instance, if you are collecting 1 for male and 2 for female, you can calculate mean with that kind of a data. So it's not a parametric data. Okay, so now we have a parametric data. It means the characteristic that we're investigating, or our dependent variable, we collected that data and the data is parametric. Then we are able to use parametric data analysis. Okay, so if we are having two groups of the independent variable, then we can calculate differences between the two groups. Okay, so sometimes we have two groups which are independent groups. Okay, for instance, I can pick a set of girls from primary school A and I'm comparing it with girls from primary school B. Okay, but the study is about school girls. So the independent variable will be school girls. But girls from primary school A and girls from primary school B will be two groups. Okay, and this group are independent because they do not relate to one another. So if there's the independent groups, you do its independent t-test. But if you say within the same group, so sometimes we have two groups, okay, but it will be two groups that we subject them to different temperature, okay. I mean, not different temperature, to different conditions. A good example would be training, okay. We take a group of girls, we analyze their level of maths, we give them a maths test, then we record their maths, then we train them or we teach them for a week, then we give them the same test, then we record their marks. So you see that we are having two groups, but it's actually the same group. So we say these groups are not mutually exclusive because it's still the same people. But it's just that we have a group at a particular time before training and the same group at a particular time after training. But in terms of data analysis, we recognize them as two groups, but it's the same people. So they are not mutually exclusive. So we can only do paired t-tests, okay, to analyze that kind of data. So for those who are dealing with animals and humans, most of the quasi-experimental design uses this type of paired t-test. For instance, you have a group of animals, you check their immune system, you give them a particular feed, then you check their immune system after. So paired t-test is used to check the differences between the outcomes. Okay, so dependent groups, independent group. For independent group, we use the independent t-test. For groups that are not independent, okay, or the same group, we use paired t-test. Okay, then now for parametric differences between group for situations where we have two groups, okay, more than two groups, sorry. So we've looked at a scenario where we have two groups, okay. Remember, you can't do a statistical analysis of variance with only one group. So that's the mistake that some students make. You find them having a research objective. When you check the research objective, the independent variable is having only one group. Then they will say, I want to do analysis of variance. Before you mention analysis of variance, you must make sure that you have two groups or more. So now let's look at the more. Okay. So if we have one independent variable, okay. So this one is mostly factor for those who are doing experiment. If you have one independent variable with two or more factors, we sometimes loosely consider each factor a group. Okay. So for instance, the independent variable can be temperature. So a temperature of 20, a temperature of 30, a temperature of 40, we can loosely consider them as a group. And they are independent anyway. So we can do one-way Anova to look at differences between the factors. Okay. Then two dependent variables. Okay. Sorry, two independent variables. So in this case, you actually have two variables that are independent. Okay. So we can do two-way Anova to see how the variables they interact. This one is rare, but it's something that is those who are doing two-way Anova will know. But two-way Anova is not something that is common with many students. Okay, so statistics decision. Now let's look at where you're looking at variance between groups and factors. So we're also looking at variance between groups or factors for non-parametric data. Okay, so non-parametric data is the one of data where we don't do means and standard deviation. Okay, so most of the categorical variables, okay, where you have categories, we don't do mean and standard deviation, and even some of the ordinal variable, mean and standard deviation will not really be meaning the same thing as in parametric data. So we treat them differently. So if your data is not the kind of a data whereby you measure and then you write down the data, then you get the numbers out of measurements, they know that you are dealing with a non-parametric data. Sometimes we do have parametric data that parametric data sets that do not obey certain rules like variance, like having the same variance when groups are not having the same variance. We treat such data as non-parametric data. So, but when you choose a statistical test or a type of statistical analysis, you must look at all the terms and conditions, all the requirements. So they'll tell you that if your data set does not meet 1, 2, 3 requirements, then you must consider using non-parametric tests. Okay, so these are the non-parametric tests that we have. For two groups, independent variables having two groups, if the groups are independent or mutually exclusive, then we can test differences using the man-witness test. Okay, but if the groups are not mutually exclusive, like I said, related group, and you see I put here repeated test, which is very important. You take the first group, you give them a test, you give them training, you do. So we call them repeated tests. Even for animal, you take the animal, you test them, you give them feed. After that, a particular feed. After that, you check the immune system is repeated test. So the groups are not mutually exclusive. So we do a Wilcoxon sign rank test. Okay. Then now for more than two groups, okay, if we have more than two groups, if they are independent, we do the Kuska-Wallis test, okay? That is for non-parametric. Then if they are dependent, we do the Friedman's ANOVA, the Friedman's ANOVA. So this one will be repeated test, but for more than two groups. Repeated test for two groups, we do Wilcoxon sign rank test. So guys, you see how important it is for you to know the type of data that is collected, because it will be impossible for you to judge the type of statistical analysis to use if you don't know the type of data that you've collected. First of all, you must check whether your data is parametric or is non-parametric. If it is parametric, then you are here. If it is non-parametric, then you check the non-parametric side when you want to analyze variance between groups and factors in the independent variable. Okay, so now let's go ahead and look at other type of data. We have association between categorical variables. I've mentioned this one earlier, is the chi-square. Okay, one categorical variable can be dichotomous. Okay, so in fact, when you have different groups of the variable, if one categorical variable is dichotomous, nominal or ordinal with independent groups, they use chi-square goodness of fit. Okay, so this one is when the groups are not independent. Then two categorical variables with each having at least two independent groups. You see, so independent groups will be male and female. Then you use the chi-square test of independence. Okay, but sometimes when you read articles and you are research, you look at research that are similar to yours, you'll be able to deduce the type of statistical analysis that they use there. Because for you to understand all these statistical analysis can be very difficult at times. But I'm just giving you a kind of a guideline so that when you see it somewhere, you can come back to this lecture and just try to get the bigger picture. Because sometimes in the articles or in the published articles, you will not be told the reason why a particular test was chosen, you know. Yeah, so hence I'm putting this lecture out to assist you to understand why we use one test and not the other. Okay, predicting relationship. Predicting relationship is a scenario whereby we want to see that if I have a certain value independent, if I have a certain value for the independent variable, it's going to affect the dependent variable in a certain way. You understand? Like those who are doing economics, you know, if the business atmosphere is in a certain way, then the economy of a country booms, you know, marketing, you know, the more customer you get, the more turnover you get. So there's always that predicting relationship. Some people predict the value of dollars and stuff like that. So regression is at play or correlation. You understand? But they are all related. Okay, so predicting relationship, degree of relationship correlation. When one is increasing, the other is decreasing, or when one is increasing, the other is increasing. So we have positive and negative correlation. Okay, but this one correlation It's rarely used in many researches, but it can be used in certain types of research. Then we have making predictions from relationship. So we have one predictor variable, or we have two predictor variable. Okay. And remember, one predictor variable is one independent variable. Two predictor variable could be two independent variables. Sorry. So it could lead to multiple regression. Multiple regression means that you have many independent variables. So it will be two or more. Okay. Then this one you can use a simple regression when you have one predictor variable. Okay. So you can see that for regression, like I said, your independent variable can have groups. You can use the groups separately. There's a way that they use the group, or you can choose to not to bother about the different groups and just use the data as it is. Okay, so that's something that you need to check out. Like I said, this lecture is just on guidelines on how to choose a type of statistical analysis. This is not a statistical analysis course. So if you are interested in any of the statistical analysis model, then you must take a statistical analysis course. Okay, this is not a statistical analysis course, I must emphasize. Okay, so this is how your Anova result will look like, So in this case, we have the three groups, okay, of the independent variables. So we want to see how they behave with respect to the dependent variable. So you see A, B, C, A, B, these are letters. If you have a similar letter, it means they are not significantly different. So you see this factor Z and X, both of them are not significantly different because you have the same letter. And at the same time, Y and Z are not significantly different because you have B and B there. But we can see that X and Y are significantly different because they have different. So we call them significant difference letters. This is something that is related to parametric Anova. Then correlation, this is how it looks like when you do correlation. So it can tell you whether it's a strong positive correlation, then you can have a weak positive correlation, strong positive correlation. So there are numbers allocated to that. So a correlation of 1 is the strongest and a correlation of 0 is the weakest. And in between you have different levels. So you can compare how different independent variables respond to the dependent variable by looking at the level of correlation. Then one thing I must say about correlation is that you can do correlation for both parametric and non-parametric data. Yeah. So sometimes you can just choose which type of correlation you want to use, whether it's Spearman's or Pearson correlation, But Pearson correlation, we normally use it with quantitative data, and Spearman's, we use it with quantitative data, but from categorical data. So it's quantitative, but from quantitative or nominal data or ordinal data. So you must just check check that, make sure you're using the right one. Okay, but for Pearson, make sure that you have numeric data. Okay. So for regression is actually a line where you have the independent variable affecting the dependent variable, and you have an intercept. So there is a way that they work out the slope. So those who know about y equals to mx plus c, that is an example of a regression. Okay. So you can also use it to judge how independent variables relate to the dependent variables, by using the slope. So I'm just showing you a little bit of that. So, but if you want to know more, then you need to take a statistical analysis course. Okay. So regression, like I said, is this line y equals to bo plus B1 bx. So you see B1 is the gradient, BO is the intercept, and the independent variable is x1 and the dependent variable is y. So we can also have multiple regression when there are more than one independent variable, as you can see here, x1, x2, right up to xn. So this is the generic formula for multiple regression. Okay, so now I just want to talk about parametric versus non-parametric data. Okay, so how do we recognize our parametric data, or how do we use it? How do we use it in terms of data analysis? Normally, when we have parametric data, for us to use the parametric analysis, we say our data set must follow a normal distribution, and there are ways to test it. I'm not going to go into the details. Okay, and also we should be talking about mean, and the data must be in a ratio. Okay, 0.1, 0.2, 0.3, and then homogeneous, the variance. We assume that they have a unified variance for the whole group. And then our groups or factors must be independent if we want to do parametric data analysis, like the Anova, the t-test. All these assumptions or all these parameters must be taken into consideration. But you see, for non-parametric data, so that's why we say if you have numeric data, which is not the variance are not the same, and it is not normally distributed, hence the variance will not be the same, and you are not sure whether they're independent group, then it's better you do non-parametric data set. If the parametric data analysis conditions are not met, then people are advised to do non-parametric data. Because see, we don't care about normal distribution. We don't use mean, we use median, Then we can do it for ordinal and nominal scale and homogeneous. We can do it both for, we don't care about the variance anyway. Whether it's dependent or independent, we don't really give a damn. So long as we have two groups, so we can apply non-parametric data analysis. You see. So sometimes if we don't find joy with our data in terms of meeting all the requirements for parametric data analysis, then it's safe to do non-parametric, even though it's not going to give you some few details, but it's better than nothing. So let's see the type of parametric tests and non-parametric tests. We have the independent sample t-test. As I said, that is a two groups differences, analyzing variance between two groups, okay, which are independent for parametric tests. So it means the data set must have met all the parametric analysis conditions. Then the groups are independent. Then we use a t-test to check for variances between the two groups, okay? But if they are not independent, we use a paired sample t-test. I've mentioned that, okay? And then we use a one-way ANOVA for two or more groups that are independent. Okay, for repeated measure, okay, we use one-way ANOVA repeated measure. So we also have for groups that are not independent. Then for the parametric side, why we are using independent sample t-test for groups that are mutually exclusive, groups that are independent, we use Mann-Whitney tests if our data cannot meet up with the parametric criteria. So for non-parametric groups that are coming, groups that are coming from repeated tests, that is the same group that we treat them at different times. We use a Wilcoxon sign rank test. So for those who are doing survey or those who are doing quasi-experimental design, whereby you take a group of people, you test them, you train them, then you test them again, you'll be using Wilcoxon sign rank test if your data is not parametric. Okay. Then Kruskal-Wallis for non-parametric analysis, if you have more than one group, they use Kruskal-Wallis to test differences between the groups. Okay. Then if they are repeated groups, You can use the Friedman's for more than one. Remember, Wilcoxon is for two. Friedman is for two or more. Okay. Petty's test is for two. One-way Anova repeated measure, two or more. Independent groups for two. One-way Anova, two or more. Man-Whitney's test for two. Kuskawali's two or more independent group. Related group, Wilcoxon sign test for two groups, and Friedman's Anova for two or more groups. Okay, so this is just to enlighten you. You can go and study more about each of these types of tests. Okay. Okay, multivariate data analysis. So this one we're talking about multiple variables. Okay. Multiple regression, like I said before, you have many variables. Okay. There are just many variables. There are many of them. They have multivariate analysis of variance. This one, there are also many variables that you are analyzing, many independent variables. Okay. Then factor analysis is also, it could be one independent variable with many factors. Okay. Then cluster analysis, and then principal component analysis. So all these ones are, you can see high level analysis involving some of the basic analysis that we've seen. So if you are interested, you can look at them and see how they are used. Some of the analyses are popular in certain disciplines and not in other disciplines. So when you are doing your literature review, you should be checking the type of analysis that are popular in your discipline. Okay. So yeah, I just want to show you when to consider a one-way Anova and when to consider a two-way Anova for those who are doing experimental design. Okay. The independent variable is where you look at the independent variable, and then you see how many independent variables are there, or how many factors have they got. So like I said, if you are doing experiment, one-way Anova used to test the equality of mean between experimental groups. Okay, number of independent variables is one, or number of factors. So this is kind of factorial design kind of a research. So that's why we're using factors here. One, then the levels of factors could be three or more, or it could be one independent variable with three factors or three groups, you see. But for Anova, we normally use the word, when we're doing experimental design with Anova in mind, we use factors. Okay, you can call it independent variable. So for one-way Anova, the number of factors should be one. For two-way Anova, you must have two factors or two independent variables. Let me say so. Okay. Then they should have levels. For one-way Anova, you should have three or more, because if it is two, then you should be considering t-test. So three or more levels of your factor or of your variable, then it's one-way Anova. Okay. Then for two-way Anova, multiple levels of two factors, multiple levels of two factors. Yeah. So you see that you have two groups or two factors, sorry, or two independent variables. So each must have two factors at least, or multiples of two. That's what they're saying here. You can't have three factors, no. It must be two factors for each, or multiples of multiples level of two factors. Yeah, multiple levels of two factors. It means you can have 2, 4, 6, but not, it should be multiples of 2, something like that. Number of experiments per group. Okay, this one is just the number of experiments, like the replicates for those who are doing experiments. You know, it need not be the same. So for one factor, you can do 3 experiments. Another one, you can do 5. No problem for ANOVA, because we are looking at the mean. But if you are doing two-way ANOVA, it must be the same. So the number of experiments you do for each factor must be the same. Then design of experiments. So for one-way ANOVA, you need to satisfy 2 principles: replication, randomization, and control. So you must have a control experiment there. But you should be doing all these 3 in all kinds of experimental design anyway. Randomization means that you must select your samples randomly. Replication means that for each factor, you must do the experiment 3 times or 2 times. If you don't do the experiment at least 2 times, you will not be able to get means, because you need 2 or more to calculate mean. Then you must have a control. Okay. So variables, factor, levels, and treatment. So this is mostly factor design. When you talk of factor design, you automatically think about ANOVA. Okay. Whenever you are hearing about factor design, experimental design where you have factors, then you must think about ANOVA. Okay, because the independent variable is called factor there. Okay, then the dependent variable is called responses. So that's just something that you must take note about ANOVA kind of experiments. Okay, then the factors can have different levels. So example of a factor will be temperature. Okay, which is an independent variable. Okay, sometimes we call them independent variable, yes. Then we have the levels. Now we have temperature can be 30, 60, 90. So temperature is a factor and pH is another factor. Or in this case, we say it has 2 independent variables. So we call them factors here. Then they have levels, you see. Then treatment will be a set of factors. So we'll take for 30. If we say I'm doing replicate, it means I must subject the system to 30 degrees and collect the data, subject it again to collect the data. I can do it 2 times or 3 times. That's what we call replicates. You do the same for 60, then you have a huge data set. Okay. So the same for pH and that's it. So response example, we can have growth rate. Okay, we subject things to temperature, we check the growth rate, gelation, death rate, weight increase, brightness, viscosity. I increase the temperature, I check the viscosity, I do it at 30, I check, I do it at 60, I check, I do it at 90, I check, and then I come again, I'm doing another replicate, 30 again, 60 again. And then I subject the system to 5, pH 9, I check. So this one is, you see how I can subject the system to one-way or two-way ANOVA, depending on my experimental design and what. If I want to see how both temperature and pH at the same time affect viscosity, and then I'll be doing two-way ANOVA, because I'll be having 2 independent variables or 2 factors. That's what we said, that for you to do one-way ANOVA, you must have only 1 independent variable or factor. Okay. So one-way ANOVA, it means we have 1 independent variable, which or 1 factor, which will have different levels. So you can see these are the levels. So I said temperature has these levels. And then in this case, double arrow means I'm going to do a replicate two duplicate analysis. So the replicate will be 2. It means I'm repeating this experiment 2 times. Then I'll have the data here. Okay. So this is a kind of a mind map for one-way ANOVA. If you know your independent variable, then you check out the levels. Then you know that you can make a mind map or your experimental plan. So this one will be for two-way ANOVA. So you see, I have 2 sets of independent variable. The first one is temperature, which is this. then the other one is pH. So for each value of a temperature, I must do a corresponding value for pH, and I must do it twice. So you can see now that it's getting complicated if you are doing two-way ANOVA, because now it means that you must do combination of temperature and pH. Then you will get many experiments to run. In this case, let's see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I must do it each one twice if I'm doing duplicate. So it takes me to 18 experiments that I must run in the lab. That's it. That's why I say one-way ANOVA is more popular than two-way ANOVA. And the data analysis is also complex. So ANOVA assumption, these are the assumptions for ANOVA. So like I said, every type of statistical analysis, each one has got its own assumptions that must be made and must be fulfilled before you use that particular data analysis. Some people think that you just enter your variable and just run data analysis. No, you must check all the assumptions. Look at ANOVA. Each group sample is drawn from a normal distributed population. So the population must follow a normal distribution. So you must know about the population upfront. And your data also must follow that normal distribution to confirm that. And all the population, the variance of the population must be the same as the variance of your sample. There shouldn't be a difference. Those who know about this kind of experiments know what I'm talking about. So if you are using ANOVA and you don't know about population variance being common variance, then you need to start to learn more about it. All samples are drawn independently of each other. So this one is a kind of a random sampling. If you do a random sampling, then you meet this condition. You see. So within each sample, the observations are sampled randomly and independent of each other. So the samples must not be related. Hence, we say independent sample or independent group. You see, so if you are sampling within levels, they should not be related to one another. So this one, they're just talking about independent groups. So you must sample from different levels. Then we have the Kuskawalis test. So we've looked at ANOVA. Let's go to Kuskawalis. Kuskawalis is the ANOVA for non-parametric data. So what Kuskawalis does is to tell you whether two groups are significantly related or not. So it makes Kuskawali makes some kind of a pairwise comparison. So for example, let's look at this one: walking, jogging, and running. So the effect of different exercise regime, walking, jogging, and running on blood pressure. So Kuskawalis will compare walking and jogging. Was the blood pressure significantly different or not? Okay. Okay. Kuskawalis will ask you whether walking and jogging were significantly, the blood pressure was significantly different between the two regimes. Then it will do a pairwise comparison, just like ANOVA. But there's a slight difference, is that you can't generate significant letters from this one. That's the main difference between parametric ANOVA and Kuskawalis. Then you have Don's multiple comparison test. Okay. So like with ANOVA, if you do ANOVA and then you get a statistically significant result, then you proceed to do the post hoc test, okay, to look at which group are different from one another. But in the case of a Kuskawalis test, when Kuskawalis test say all the groups are significant, like here, there's a significant test here. So for all this group with significant tests, you can do Don's comparison to look at what level did we get significance, or how much significance did we get. You see, so let me read what Dawn test is conducted to determine whether there is a statistically significant difference between the medians of 3 or more independent groups at some level of significance. So for Dawn's, we are looking at various degree of significance. Okay. Unlike the post hoc test for ANOVA, where we are going to get significant letters. Okay. So don't think that when you run a Dawn's multiple comparison test, you are going to get significant letters. No, it's slightly different. But all of them are doing pairwise comparison. But what we get in terms of the statistics output is different. So one-way ANOVA post hoc test. So we do one-way ANOVA when we find out that there's a significant difference between the mean of groups. So in this case, we are looking for significant difference. Okay. So if we see that there's a significant difference, then we do pairwise comparison to see which two groups actually differ with one another, or which two groups do not differ. You see, so you can have 4 groups, but only 3 do not differ. But overall, it's going to tell you that there's a significant difference. But meanwhile, there may be some 2 that are not significantly different. You see, that's why we do a post hoc test to see whether there are some groups that are not significantly different. Or to see which group are not significantly different. Sorry, because for ANOVA, if there is no significant difference, then we stop there. But if there's a significant difference, then we find out where is it coming from. So one-way ANOVA post hoc tests. Some examples are the LSD, the Benferroni test, and the Tukis test. Okay, so I'm not going to say much more about that. So if you decide to use any of them, then you must get the reason why you want to use which ones. This is not an exhaustive list, so I put etc. Okay. But the most popular one is the Benferroni and the Turkish test. Okay. Okay. Also, we also have you might have a good data that has mean that is coming from a homogeneous population. Okay. Then you find out that it's impossible for you to tell whether the variance is if the population variance and the sample variance are equal. You see, so if you have that kind of a data set, then you can use non-parametric approach to analyze such a data. Okay. Then you have for numeric data. If you have numeric data, a numeric data set which is not obeying the equal variance rule for both sample population, then you can also apply this type of comparison test, pairwise comparison test. We have the Dawn's multiple test, we have the Gomez-Howell, the Tam-Hens. But you should know that sometimes you might not go to all these details. I mean, if you can just realize that based on my groups based on the groups in my independent variable, I'm going to do ANOVA, is fine. By the time you collect the data, maybe you can approach a statistician for help. Okay, because I'm not saying that students must know how to do all this analysis. Okay, so thank you. I mean, if you've listened to this lecture, then you know that you have a lot to do, and you need a lot of practicing. Okay, and you need to read and do literature review. why you develop your research objective. Make sure you look at your scale. Make sure you look at the type of data you collect. Make sure you check the number of groups in your independent variable, and listen to this lecture and see how you can start to choose what data analysis to use. And also the articles you are reading, I mean, you get some information on how other people are analyzing their data, especially those people who are doing similar research like you. So I wish you all the best. Take care. Bye.